G'day and welcome back. Today I've got something completely different. This is the chassis out of an STC 732. It belongs to Steve. Steve contacted me some time ago and said he wanted to fix this radio up. He'd got hold of it. He watched my videos and he said he'd like to be able to repair it. Steve doesn't live far from me, so I said bring it around, we'll check it out and see if it's able to be repaired. Everything seemed to be okay. I think it could be repaired. I did notice that the speaker field coil was reading under its DC resistance. It's supposed to be 2.5k and it was 1.6 or something. So I said to Steve, go and do it, and the coil can be rewound. That won't be a problem. I flipped the radio over. I'll show you the bottom here. Steve took it home and replaced the capacitors and did a pretty good job actually, considering he's not done any of this sort of work before. It's pretty good. However, when he put it on full power, it blew this capacitor out straight away. He also said this little rheostat here that's mounted on the back, that started to smoke. After exchanging messages for a little while, I said, look, bring it around, leave it with me and I'll have a look. I replaced that capacitor with a 600 volt capacitor. I think he had a 450 volt capacitor in there. Here's a photo of it and you can see the end of it's blown out there. If you look at this plate here for the rectifier, you can see the remains of some of the capacitor there. I need to clean that off. So after replacing that capacitor, the amplifier wasn't working. And then I realized he'd forgotten to put the coupling capacitor in. So I've put a coupling capacitor in. Even with the coupling capacitor in, it still didn't work. I found this rheostat here on the end here. This adjusts the grid bias for the, I think, the two front end tubes or valves. It's like a sensitivity adjustment, I think. It wasn't working, so they were getting no grid bias. Once I replaced that, the radio started working. This is the speaker and this is the field coil, and I think it has a short in it because it's not reading the correct DC resistance. It's too low. This is the metal cover off the speaker, and as you can see there it says 2.5k ohms or 2500 ohms. That's what it should read, and that's a DC resistance. So here's the circuit diagram for it too, and that confirms that it should be 2500 ohms in the field coil. I started to dismantle the speaker before I filmed it, so this is upside down. This normally sits on top of the speaker, and I've connected my two probes for the multimeter here, and it's reading 1.5k. That should be 2.5. So there's got to be a short in there somewhere. Before I go too far, I'll just explain how these electrodynamic speakers work. This is the field coil here. This is the core. The field coil is supplied with rectified AC, and it magnetizes this core. So the field coil is made that magnetic. This bit of cardboard here is the voice coil. It has wire wrapped around the outside of it. So the core fits inside that voice coil, and the voice coil reacts against it with information that it's getting from the radio signal. That hum is also broadcast along with the signal from the radio, so you can hear the hum. The way they combat that is to use a humbucking coil. As the name suggests, it's bucking the hum that's being produced by the field coil. The humbucker coil is wound in phase with the field coil. It picks up the same hum that's being produced by the field coil. It is wired in series with the voice coil, but in the opposite phase. So the voice coil gets the same hum, but it's 180 degrees out of phase with what's being produced by the field coil. Because it's 180 degrees out, it cancels itself out. So the humbucker coil takes care of the inherent hum that's produced from the field coil, but the field coil is also very good at blocking AC. AC doesn't like traveling through a coil. It tends to cancel itself out and it passes DC. So it's a very good filter. So radios that use these electrodynamic speakers generally have smaller filter capacitors. They don't need quite as much filtering. Now comes the tricky part. I've got to work out how to get enough wire on here to get 2.5k resistance DC. This is 0.13 millimeter wire. That's the closest I could get. This is the original wire. I've cleaned off the insulation and it's measuring at 0.12 millimeters. I'll measure the new wire and make sure. This is the new wire. I've cleaned off some insulation and we'll just see what that is. And it's the same. It's just slightly less than 0.12. Okay, so it must be about the same. So I'm still not sure how I'm going to do this. What I've done is cut 2 meters of the new wire off, and I've cut 2 meters of the old wire off. I'm going to measure the resistance. I have my multimeter over there. I'll clip the two leads together and we'll get a baseline. So that's coming up as 0.08. I've cleaned the insulation off the end of the wire, so I should be able to grip it. There's the second one. I've got 2.85 now, so 2.85. needed minus 0.08, I think. So that's 2.77. Here's the old wire here, so I'll put a clip on that one. Okay, it's hovering there about 2.43, so I'll put that down. So 243 minus 0.08 is 2.35. So a little bit of difference in the two wires there. That's surprising. Anyway, we'll use the new number. Now that was for 2 meters, so I need to divide that by 2. So that's 1 meter. Put it in memory. I've got 2500. Divide that by recall memory equals, according to that, I need about 1800 meters of wire. I will need to make a new bobbin to put the wire on, the new wire. Now this core here looks to be 1 inch, so it'll come out at 25.4 mil or something or other. Yeah, so 20. So if I make the bobbin 25.5, that should be okay. That should clear that. Depth, I've got to do the depth. Now, there's still bits of crisp cardboard in here. I'll just get them out of the way. I can now see the bottom plate, or the bottom cardboard that it has there, so I can measure from the top of the coil to the bottom of that plate. It's coming up at 44.35 millimeters. There's a piece of board top and bottom of the coil, so I need to measure that as well. And we got 0.6 there, so that's 1.2. I've added the thickness of the two cardboard ends to the height I need, and it's come up at 45.55. So this is what I need. I'll go and print this out, and while it's doing that, I'll set up my CNC winding machine. I've got my CNC winding machine out, and I've set it up. I've 3D printed a new bobbin, and it's mounted on the arbor there. I've come up with a cunning plan. I've mounted this meter on here. It has the wire wrapped around the wheel, and every time 1 meter of wire passes through, it'll count to 1 meter. It's got a little jockey wheel there that just keeps a bit of pressure on it, and there's a clothes peg there that's adding some tension to the wire as it feeds on the wheel, otherwise it'll just fall off. I've powered up the CNC machine. I've already programmed it, so it should be ready to go. If I push start, this will move over to the start position. I'll just wind that bit of wire on. The meter's on 0. I'll push start, and hopefully it'll work and not break the wire. This is going to go so slow, but I didn't want to go too fast. It looks like it's the wire here is leading the feed. I might need to increase the diameter of the wire. Here, there it goes. Alright, I'll have to reprogram that. Right, it's all going again. It looks pretty good. I've set the width to... no, it just broke. What? Why did it break? As you saw in the last bit of video, the wire broke, and it broke here. This got a knot in it and got caught on this little friction pad that I've got here. So I bent up a bit of tin, put a little grommet in there, and that will guide the wire and stop it from spooling outside here. I also put a bit of PVC pipe around here, and that should stop the wire falling off. So hopefully that'll fix the problem. Now, of course, ideally the spool should be mounted horizontally and just pull the wire off, but the spool is so heavy and the wire is so thin, it just breaks every time I try to do that. So I've gone back to this method. I've got the counter on 0. I've got this ready to go. I'll push start. We'll see what happens this time. Looks good so far. I think I need to make that wire diameter a bit thicker. If I push stop, I can push edit. I'll make it, maybe I'll make it 14 for the second. So I'll make it 14. I've just reprogrammed the wire thickness. It seems to be just lagging slightly, so I don't want it to do that. So we'll start again. Yeah, that's definitely lagging. I'm going to make it 15 just so it can catch up, and then I'll adjust it again. And hopefully that'll catch up a bit, then I'll go back to the 14. Broke. It's broken again, and the wire actually wrapped itself around the little guide that I made. So it looks like back to the drawing board. I've made a little cardboard cap to fit over the PVC pipe here, and that'll stop the wire flicking up and around like it was on the other design. So hopefully this will work a bit better. I've reset the counter, push start, and we'll see what happens. Looks good so far. I'm not going to bore you to death while I wind this for 3 hours, so I'll keep the camera running. If something happens, I'll show you what's going on. But so far we're working well, the counter's working, it seems to be winding alright, the head up here is keeping up with the wrap on the spool, so it's looking good. Okay, just coming up to the other wrap, it's going to come along the edge here and come backwards again. There it goes, and this end here was very, very good. It's perfect actually, it's perfect. We're getting close to 200 meters. My little dispenser seems to be working alright. The wire's winding on pretty good. It's got a couple of little defects in it, but it's not bad. Let's come up to 200 now. So 200 meters, 1600 to go. And we're just coming up there to 900, so we're halfway there. Now something about the counter, it only goes to 9999, so when it gets to this end of the spool, I have to stop it, reset it all, and start again, otherwise it's going to run out. You're very close. Alright, stop. I'll put a little bit of tape behind there. I need to unwind put some slack in it at least. Alright, that should be enough. If I push reset, okay, push start again, and I'll put some tension back in it. Get this tape off, we should be okay to start again. Okay. Alright, we're just coming up to the target, which was 1800. I think it was a little bit over 1820 or something. I'll let it go that little bit further, but I'm a little concerned because this coil is nowhere near as thick as the original coil. This is coming up to 1820. I'll stop the machine. Here's the original coil, and I'll just roughly measure it. It says 5 centimeters, and the new coil is about 4.5. I need to know if I've got enough wire wound on here. I can scrape the insulation off and check, but then I've got the problem of re-insulating the wire if it's not enough. I think I'll wind a bit more wire on and then check it. I've wound a bit more on till I'm in the center here. It was over right on the edge here. So if I tape that off there, and I'll check the resistance. I've cleaned off the insulation here, and I've put my meter on, and look at that, 2.6. I was after 2.5, so I have gone too far. I'll wind some of the wire off to get closer to the 2500 ohm. I'm not going to get too worried about it. As long as I'm ballpark, I'm quite happy with that. So let me take some wire off. I'll come back when I've finished. I've removed the coil from the machine. It's wrapped with Tipton tape. I have the little fly wires out here. I'll have to join main wires onto that. Something I didn't point out, of course, was that I wound this in a particular direction, and it's the same direction as the original. So I've got the direction marked there. This goes to the back of the speaker, so I've marked that with back. I took the wire off the old core here, and it's rusted on. That paper there, the cardboard, is just totally rusted onto the core. So I'm going to have to scrape it off. If it has got rust under there, I'll sandblast it and I'll paint it with some zinc paint to stop it rusting again. Now, something I didn't physically measure was the width of this coil, so I hope it's going to fit in there and end up in the same place. It should do. I did measure it all, but I didn't actually check it because I left the wire on here. I was a bit too scared to take it off in case I needed it. But anyway, the other thing is I managed to find the short in this, and I got rid of it, and I was able to measure this old coil, and it was 2600 or 2.6K. So even they had gone over the 2.5K, so I could have left it where it was. I think I ended up with about 255, so 2.55K. So what did I learn? What I did learn is that this magnet doesn't have as many turns on it as the old wire. I don't know why it has a higher resistance. It's not as pure as the old stuff, or it's just a different copper. I don't know why. It may have been better to match the resistance more than the diameter of the wire. This wire is exactly the same diameter as the old one, but it obviously has higher resistance. It's left me with less turns on here, so it's not going to have the same magnetic power that the other one did. I think it'll be okay, but in future it may well be worth taking into consideration the resistance per meter compared to the old wire, and not just the thickness of the wire. That is, of course, making sure it still fits on the spool. I shall take this cardboard off here. We'll see what it looks like. I'm assuming it's rusted on. I wonder if they glue it on. Maybe it's glued on. The only reason I said it was rusty, it smelled like rust as I was taking the old wire off. Yeah, it is rusty. So I'll have to go and I'll sandblast it and put some zinc primer on it. There's the original mark. We'll see how close this goes. Please, 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 please. Well, I can't see the mark. I'll put a pencil mark there so it's give me an idea. Yeah, it is sitting up a fair bit higher. There is another bit of board down there. I can get that out as well. If I put a bit of pressure on there, you can see the old line. So this spool is exactly the right height. I put the core in the media blaster and it came up very, very well. But I've put a bit of zinc primer over it just to protect it. I masked this area off. This is where the voice coil goes. I didn't want the primer up there. I've also attached fly leads to the very fine wire, so that's secure. I just want to put a bit of this press paper around to make it look a bit more like it did back in the 30s. Okay, there's the back, so that goes towards the back of the speaker. Good. To reassemble this, I need to take the cone out. To release the cone, there's two screws here and it's holding a spider underneath. The cone is actually loose around the edge here, so it'll just drop out. Now the screw's down here, so it's coming off luckily. I need to desolder the voice coil wires as well. Okay, with all that undone, I should be able to just lift this off. And there's the cone. With the cone out of the way, I can now fit that, and I'll put the bolts back in. I've put the bolts and nuts in. The edges here of the inside of the basket were so rusty, I ended up taking it out and putting it in the media blaster, cleaning it all off, and I've put some rust guard primer on it. I did the same STC speaker a while ago, and this plate and then the core, magnet core, need to be aligned, and I made up a little alignment tool. I've printed it, and that aligns the core in the center of this plate and this plate in the center of the basket. So you can see they're all moving independently. So this fits in here and should center everything. That's a pretty tight fit, so it'll take a few seconds to get it in. There we go. Right, so that should center the core, the plate, and the basket. So I can now do the nuts up. That'll stay there. I'll do the nuts up and that should be all centered. Now the tricky bit is getting this out. Oh, there it goes. Okay. That looks pretty good. It's right in the center. I can put the cone back, but I need to cut this center screen out. I'll have to replace it with a bit of felt. Right, I can put the voice coil in. I have the wires facing the audio output transformer. And that should fit over there. And just spin it around to the whole lines. There it is. Now my standard idea here, I put little bits of plastic strip. These are off berry boxes like strawberries or blueberries. I've actually put a little bit of a curve in the plastic there to try and follow the shape of the core. Oh, I'll tell you what, this is tight. Very tight. There we go. You have to be very careful you don't damage the voice coil. You can go through it if you're not careful. But that's pretty much centered that, I think. I need to tighten the two screws holding the spider. There's the first one. Alright, there's the screw in, done up. Spider's all done. I'll remove the little plastic bits in there. That one wasn't in quite well enough. Might have to do it again. Let's see. Oh, it rubs like mad. Okay. I'll have to do it again. I've put the three little plastic strips back in. I just need to loosen the nut and bolt off and tighten them up again, and it should center. Okay. Okay, I've taken the strips out. Let's see. They're still rubbing a little. That's a nuisance. Alright, I'll just keep doing it until I get it right. I did this again and it's perfect. Not a sound there, that's perfect, it's not rubbing. I just made a small change when I did the nuts up. I'll show you what I did. This is the spider that supports the base of the cone and the voice coil. There's the two nuts and bolts that I've been doing up. Because I was letting the nut rotate when I was doing it up, it may have been skewing the spider a bit, and that's why it wasn't centering. Once I put a spanner on there to hold onto it, it centered perfectly. I replaced all the wires going to the speaker, and this is them coming over the edge here. I've tacked them onto the speaker socket on the back here. I'm going to test it before I solder the plug on and put some wrap around these wires. If it's not going to work, I don't want to have to undo everything I've just done. I'll put some power on. I've got it on dim bulb, just in case. That seems to be okay. Oh, I can hear something. I can hear something. Where are we? Volume?
And it's great to be sitting alongside former South Australian keeper.
Hey, it works.
Good to see you. What a night.
Andrew, we are in for an absolute cracker tonight and very excited to be here.
Former Adelaide striker spinner Hannah Perry is here as well. Great to see you, Hannah. Excited about this one?
Yes, you too, Andrew. Dino, great night.
Okay, well it does work. I'll put it on full power. Alright, let's turn that up.
Got 15,000 they want to get in tonight. They will all be cheering on the strikers. They've had a well-rested week.
I think that's the women's cricket. I'm also monitoring the B plus at the output valve, and it's 234 now, and that was up at 300 odd before, so that's a good result. That's what I hope to get. That seems to be working really well. I put my finger on the coil a second ago and it's not even warm yet, so it should be okay. I think I'm safe to put the plug back on all the wires there and finalise them. I've put some wrap around the speaker wire. I've stripped off the ends here and tinned them. I'm going to put them in the plug here, and I've just written the colours on the pins there, or on the edge there on some tape, so a bit easier. I do have a mud map here, but I just put it on here. It makes it a bit easier for me. So that one's black, so simply a matter of putting it in there. It'll come out the other end, I hope. There it is. I've cleaned all these holes out as well, and just a matter of putting some solder on the end there. The wires are all soldered in, so I can put the cap on. I did remember to put the cap on before I soldered them on, and we're finished. That looks pretty good. Yeah, okay. I can put the protective cap on now. When I was testing this, I had some clothes pegs around the edge to hold the cone down onto the basket. Now I just need to get in there. I'll squeeze some glue in there. I can glue this down. And the only thing to do after that is make a little felt cover for the core. Well, it's all back together. I think I can give this back to the owner. It's working quite nicely. I'll turn it up.
That she brings in from Ireland as opposed to I guess an elect.
Earlier in 2019 and 2020, it had to move on.
Yes, it works well.
When it comes to the language
Situation. It is. He is a winning machine since he joined Dane Smith.
Yeah, so the radio works well now. The speaker sounds quite good. I ran some music through it last night and it sounds fine. So it doesn't have any noticeable issues having the slightly smaller magnet, so I'm happy with that. But boy, did I have to learn a lot about dynamic speakers, humbuckers and voice coils just to work out how that all worked together. And I hope my description earlier was correct. That's the way I understand it, and I'll bet there's variations to the way you do it. I have seen speakers with the humbucker wound on the outside of the field coil. There is very little information on the internet regarding dynamic speakers and rewinding coils. I did find a channel called Restore Old Radios. I think the channel operator's name is Don. So thanks to Don, and I'll put a link in the description for this video to his channel. And I was very happy when I was able to measure the resistance of the wire, work it out, put it in the counter, and it came out pretty accurate actually. And before you put it in the comments, I know there's copper wire resistance charts, I know all that, but I wanted to know the resistance of the wire that I was using. So I can send this back to the owner, Steve, and he can finish off the wiring and any other little jobs he wants to do to it. So very successful. The speaker sounds great. It's working again. I've learned so much, and I hope you enjoyed watching it. And I hope you can join me next time for my next radio adventure.